Let's take a look at a basic normal distribution problem. I've presented the graphic here so that you can see it. You also have a copy of this in your Moodle course that you can print out so that you'll have it. We can look at these things, these symbols that are here in this graphic. This X with a bar over it represents the mean. The S in this graphic stands for standard deviation. So if we look at a basic problem, it says the lifetimes of 10,000 watch batteries are normally distributed. This is important that whatever it is that you're talking about is actually normally distributed. We would need to make sure that we understood that whatever it is that we're talking about is actually normally distributed, and that, you know, that it's either understood or it's given that that is the case. So this is the mean lifetime, and it should say of 500 days. The standard deviation is 60 days. So when we look at our graphic, we have a mean of 500 days. So when we're labeling one of these problems, we would put the mean there. Standard deviation is 60. So one standard deviation above would be 560. And you keep adding and you keep subtracting. So 500 minus 60 would be 440. And then, you know, you add and subtract on each side of it. So if we put 560 plus 60, we would have 620, plus 60 more would be 680. So I've labeled my standard deviations above. Let's label the rest of them below now. 380 and 320. So I've labeled all of my standard deviations. I've labeled the mean, which is what it says. It says sketch a normal curve. This is a sketch of a normal curve. So this bell-shaped curve with the mean in the middle is your sketch of a normal curve, and that represents the distribution. I've put the mean in the middle, and I've labeled the 3 standard deviations on either side of the mean. It says estimate how many watch batteries will last for each of the following intervals, 440 to 560 days. Now, this is where these percentages are important. So 440 to 560 is here. And the percentage that is in my graphic for this would be 34 plus 34, which is 68. So 68% of all of my batteries will last that number of days. So I would take 0.68, which is 68%, and multiply it by my 10,000 batteries, and I would get 6,800. So that first one would be 6,800. The next one says 380 to 620. So 380 to 620 is here, and that's 13.5 plus 13.5 plus the 68% there in the middle, which is 95%. So 95% of my 10,000 let's make sure it was 10,000. Yeah, of 10,000 is 9,500. So that's how many would still be, which would last for 380 to 620 days. Well, 320 to 680 is here. And if you add up your percentages, what is 2.4 plus 0.1 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.4 plus 0.1. If you'll notice, if you add all those percentages up on that graphic, you get 100%. So 100% of those lifetimes, those watch batteries, would last 320 to 680 days. That's the lowest is the 320, and the highest is the 680. So that fits within all of your standard deviations that you have. So that's the purpose of this that you're looking at. The mean lifetime is 500. You've got 10,000 of these watch batteries, and so when you're looking at these percentages, you're saying, what's the percentage of these watch batteries that will last? The percentage is marked in your graphic. The standard deviation is marked at the bottom. And so all of these problems would be similar in that way.